You guys will like this again because we're going to deal with, well, kind of some of the acronyms that we've done before. You guys remember side, 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 side angle side, all that kind of stuff. Remember when this used to work? There we go.
Oh.
7.3, similar triangles. By the way, that sign means what? Similar.
I thought it was the squiggly. Oh yeah, I thought that was an
Okay? Congruent is basically that with an equal. Since they're not quite equal, we get rid of the equal, and what do we have? Similar. There we go. We're going to talk about similar triangles. If triangle ABC is similar to triangle DEF, then dot, dot, dot. Let's draw a picture here. What do we know about the angles? If they're similar,
They're congruent.
so angle A would be congruent to what?
Angle D.
Angle A is congruent to angle D. What else?
Angle E is congruent to angle E.
Angle B is congruent to angle
That's
E. What else?
angle C is congruent to angle F.
Everybody okay with that so far?
Oh,
Okay.
is that supposed to be squiggly line? I thought that was an N.
Some pretty bad end.
That is.
If that's how you draw 'em.
No, not like that.
Anyhow, the other way was pretty bad end, if that's how you draw 'em. Now, what do we know about the sides? The sides are what? What was the word? Proportional,
Proportional.
right? So we know that AB is over BC is equal to what? Let's see. What would be the one proportional to the AB on the other side?
DE.
And what I do with that to sometimes mark it is make a squiggly line. Okay? Over which one is proportional to the BC?
Yeah.
Very good. What's another proportion I could write? AB over, instead of BC, I could do what? AC would equal, what is proportional to AB?
D.
Over, what's proportional to AC? DF. And what's the last proportion I could write? I could go BC over what? AC. BC over AC is equal to what? EF DF. And I could also flip them around, couldn't I?
Yes.
as long as the ones that correspond to each other are at the same part of the fraction.
So you pretty much just wrote that in every possible way that you could?
No, I could make it BC over AB is equal to EF over DE. You see what I mean? I could do that. But basically, I wrote the different proportions. The only thing you could do is flip everything, the reciprocal of everything. Well, this is the sides being what?
Proportional.
Proportional. Okay? And this is the angles being what? Congruent. Whole reason we went into that big whole spiel there is to realize that we don't have to prove all 6 of these to prove that the two triangles are similar. What we're going to learn is shortcuts to prove two triangles similar. The first one is called SSS, but you know what they put on the end here? That sign for what?
Similar.
Similarity. So how you would say that to yourself, you don't say SSS, you say side, 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 similarity. That's what you're talking about there. The other one, side, angle, side. And then what do you put on the side?
Same.
So side, angle, side. Similarity. In this section, that's the only two we're going to deal with now. There are more. But it's kind of like when we did these with side, side, side congruency and side angle, side congruency. We only did 2 of them at a time, didn't we, in a section? What do you think side, side, side similarity is going to mean? Now, in congruency, it meant that corresponding sides were congruent. In this case, do you think that's what it's going to mean? Are the sides necessarily congruent in similar triangles?
No.
They're what? Proportional.
Could you briefly explain the side angle side thing again? Like how?
Oh, yeah, I will. Oh, yeah, I'm
how
going to.
you know? 'Cause I've always been so confused.
Okay.
That was my least favorite thing.
Side,
'Cause like that
basically, if this ratio, if these two are proportional, these two are proportional, and these two are what? Proportional. Then it's proportional by what? Side, 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 similarity. So what you say here is that if AB over DE is equal to BC over, what does it correspond to? EF, and AC over what?
DF. And then side, side, side similarity.
Your sides that are proportional need to be on top of each other or beside each other. Here I put them what? AB correspond to what? DE. So I put them beside each other. I could have also written this as AB over DE is equal to what? BC over EF. Or here I could have written this as AB over what? Equals AC over what? Or I could have written this one as BC over what? Equals what?
AC over DF. kind of like the same from our other assignment when we had to
Mhm.
like, write down the proportions
Yes.
or whatever?
But normally how you'll write them is how we did them here, which you'll put the sides that correspond to each other over each other is equal to the other two sides that correspond to each other over each other. So you see how the copy of AB that was shrunk down is what? DE, isn't it? So we put those over each other in a fraction.
Now, is that the same thing with our squared stuff like that?
Yes.
We put like WC.
Right.
is so-
BC, what's the copy of BC?
Yeah.
The side shrunken down, I guess. EF, so you put those over each other. Which one's the one just a lot like AC, either shrunk or made bigger? DF, you put those over each other. Does that make sense?
When will you ever get it right?
Huh?
Like, when will you do the ones that are,
Tell you the truth, I made a mistake there, don't worry about that.
Wait, where? So I should rewrite that?
Yeah.
So we're always gonna write corresponding sides across each other, right?
No, on top of each other. You can write them beside each other too. You can write them beside each other or on top of each other. But mostly they're written on top of each other. Either way, you'd get the right answer. Now, side, angle, side. The key is in between. Has everybody got that written down?
Yes, sir.
Yes.
Okay. Side, angle, side. Whenever you have three letters, okay, and you mix one letter with two others, right? Like when we had angle, side, angle. What to think about, or when he had angle, angle, side. The location of the one that is left, like here, there's a one of what? 1S, right? The order in which it's written determines where the single thing is. Since the single thing, the A in this case, is in between the two S's, then you know that has to be the included angle, or the one in between them. In between this side and what? That side. Here, the things that you only had one of was what? S, the side. So you know its location must be in between the thing that there's two of, the what? Angle. Does that help a little?
Yes.
When you have three things here, what's the thing you only have one of? Side. Its location is related to what? Since it's outside of it, it's what? Not in between the thing that there's two of. Two angles, right? And what does in between mean? Well, it's all relative to where this one is and where this one is. The thing that there's two of. It's either going to be in between those two or what? Outside those two. But in this case, it has to be what? In between them. So the key is finding first, not your angles that are congruent, but your two sides that are proportional. So if I was to say it was this one and this one, this one and this one, the included angle has to be, now there's only one possibility. What are the two included angles that have to be congruent? Which one's in between both of those? Why is it in between? Well, these two sides created that angle, didn't they? And that angle wouldn't exist if it wasn't for this side and this side. Everyone agree? Because that's the two. Now, but how does this change? Well, it changes when the two sides you're talking about change. Watch what happens when I change to this one. Now which one is the included or angle in between? A is in between here, and D is what? In between here. So you're seeing that the thing that there's two of determines where the included or non-included angle is, doesn't it? You change where the sides are, what happens now? Let's say I went to here, 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 here. Now which angle is in between? Here and here, because it's the two sides that make that one. In between. Does that make sense? You see how the thing that there's two of determines where the other one is. If I did this, if I had these two here, but I said that this was congruent, could I say that these two were similar by side angle side similarity? Because the two sides I have, there's only one included angle, and it has to be this one and this one, right? So this is the one that makes a cuss word. This will be angle side side similarity, wouldn't it? Agreed? Because the angle is what? Outside of the two sides. Agreed? The only difference between this and the other, where the location is the same, is instead of saying these two sides are congruent, we're saying they're what? Proportional. Okay? So here, these two would be similar by what? Side, angle, side, what? Similarity. And you have to put the similarity thing at the end. Because it's not congruent, it's similar. Yes?
Okay, so say that we got angle side side. Well, how do we know? Just because of the angles outside of the sides.
They didn't give you enough information. You don't know if they're similar or not. Now, and here's the way they're going to do a lot of these problems. Give you an example like this. They'll give you something here, and they'll ask if these two are similar and why. And what they'll do is they'll say this is congruent to this. Just watch for right now, okay? We'll do another example on, and they'll like say that's 10, that's 5, and then say that's 8, and that's 4. And say, are they similar? Well, the things you've been given something about. Gabriel, how many do we have? Well, they gave us something about what? 2 sets of what? And then they gave me a what? So my only possibility is what? So, as far as their location, where they're located on the two triangles, does the location work? Is this the angle in between the two sides I have something about? The location does work. Hold on. The location works. Now I got to make sure that the two S's are what? Proportional. Well, how in the world am I going to do that? Here's what you do. If they're proportional, their scale factor should be the same. In other words, this over this should be the same as what? That over that. So, is 10 over 5 the same thing as 8 over 4?
Yes.
They both reduce to what? 2 over what? So do they have the same scale factor? Are they proportional?
Yes.
Yes, they are. So I can say, yes, they are what? Similar by what? Side, angle, side, similarity. Now, nice thing about having taken videos of things, I don't have to make you write this down. You can watch this online if you want to see that, me explain that again. Did that answer your question, Riley?
Yeah, I think so.
We'll ask it again if you're sure.
So, from them showing that there's one angle, since I already drew that on there, like
Yeah,
there-
this is given to you. You're accepting that that's
So
true.
that automatically lets you know that it's side angle side, or you have to.
No, I have to make sure that they're proportional. I had to make sure and see if they had the same scale factor. Does that make sense?
Yeah.
What they're going to do on these is they're going to give you this. If they had done this, could you have said they were similar? Because then you would have said, well, is 10 over 6 equal to 8 over 4? Well, this reduces to 5 over 2, or 5 over 3, I'm sorry, is that equal to 2 over 1? No, it's not, is it? This is 1 2/3, this is 2. They're close to each other, but they're not the exact same, are they? Make sense? So if that had been a 6, you would say what? No, they're not similar because both sides weren't proportional, were they? If they're proportional, those ratios are all the same. Okay? The ratio of this side over its corresponding side is the same as the ratio of the other corresponding sides. Okay? But it wasn't 6. I made it what? 5. So in that case, they were what? Proportional. So by side angle side similarity, they were proportional. Now, get your little red books out and we'll do a couple more examples. The type of problems they're going to give you. And like I said, guys, you're going to need to go home and do homework tonight. We're not going to, this is some stuff that needs to be explained, but there's things you got to do. Okay, they're going to identify the similar triangles. Well, I'm assuming when they say identify the similar triangles, am I on 7-3? Oh, I'm sorry, I left out one. Let's go back. Go back to your notes. I thought I'd left. There's one more theorem, and it's new. What do you think that means? Angle, similarity. What do you think it means if I had two triangles here? What are the angles in similar triangles? What are they? Congruent, right? So if you can find two sets of angles congruent, what do you think you can say? You have angle similarity. They're similar by angle similarity here because there were two sets of what? So if you got two sets of angles congruent, you know what? Right now what? They're similar. It's always better to almost leave off the easy one, right? That one's easy, isn't it?
Yes, sir.
So you
Okay.
don't even have to worry about the sides of that one.
No, you don't need to worry about it. If you got two sets of angles congruent, then you know they're similar. And the whole reason is, think about it. If two of the angles are congruent, what's the third one got to be? Doesn't the same amount left out of 180 got to be?
Yes.
These are congruent too, aren't they?
Yes.
So basically what this says is that all three angles are what? Congruent. Therefore, they're similar. So anytime you have two angles, they're similar. We have two angles congruent. So now, back to number one. In number one, first of all, we have to identify the similar triangles. Now, here's how you might identify the similar triangles. And I don't ask you to do this, but we're going to write a similarity statement. I'm going to call this X, Z, Y. It's similar to triangle. Now, what do you think, what type of order do you think this needs to be in, guys?
Okay.
In what? Corresponding order. X was congruent to what? So J needs to be first here, right?
Yes.
Z corresponded to what? So the next one is?
Okay.
So right now you know which parts are corresponding, don't you? You know that 20 over 10 equals what?
1/2. I mean, sorry, 2
2 over 1, but I'm not trying to find X here, JL.
makes
What would be on the other side?
X
Very good. See how this relates to this one? That one relates to what? The reason I didn't use the 35 is that I didn't have anything for its corresponding side, did I? So I couldn't find the scale factor. Now I just what? Cross multiply and solve. I basically get 10x is equal to 260.
260 divided 2.
Not too bad, is it? Any questions there? You guys all right with that? Yeah.
Could you just say
I'd like to see the proportion, because not all of them are going to be that easy of a number. They might relate to each other that the scale factor is 8/5, which that won't probably pop into your head. Does that make sense? As easily as the others. So it's important that we're able to recognize, basically what he saw is that, hey, this one's twice bigger than that one, right? So if that one's 13, that one's got to be what? 26. And maybe on one like that, I'm okay with it, but let's, if it's double or triple or something easy like that, maybe do it there. But you have to be able to know how to what? Set up this proportion, because you're going to get ones, not like number 2. Number 2 is another easy one. Well, not necessarily. Yes. But here's the thing about number 2. You're going to find a theorem later. Is Gabriel something I can help you with? Huh? Okay. Looking at this right here, everyone makes a mistake here. There's 2 triangles there. And yes, they are similar.
Oh, I see the 2 triangles now.
But the 2 triangles are G, H, W, and then the big one, G, I, what? What is the length of GW? What is the length of GU?
39.
What is the length of HW?
20.
What is the length of IU? Now is it a little bit easier to see?
Yes.
What is your proportion?
26 over 39 is 20 over X.
You might have tried to make this 10, and you may be right. What's 20 times 39?
30.
Or you might have tried to make that 40 or something. Who knows? What is it?
780.
Divided by 26.
30.
It is 30.
Pretty sure.
Okay. But do you see how the actual triangles that existed there was a little one inside of the big one, right? Now, why was it side angle side?
Because there's 2 sides that were congruent.
Right. It was side to angle side because this is congruent to itself, isn't it? Number 3, same type of problem kind of here, isn't it? A lot of times it will help you to rewrite the triangle to make sure you don't what?
Let's mess up.
This is S, R, T. This is S, Q, V. I know this is 36 square roots of 2, right? QV. I know this whole side is what? What is this side going to be? This side, 36 minus X? Because they basically said this right here was X, correct? So this would be 36. This part right here would be 36 minus that. So 36 minus X. This right here is 24. This whole big one right here is what? 36.
What's RT?
We don't know. Nor do we really need it. They want me to find what X is, right?
Right.
Tell me what proportion I could write.
Side angle side.
What would my proportion be? 36 over what?
24.
Equals what?
X over.
Nope. What's this one corresponds to that one, right? So 36 over what?
3x minus.
36 minus what? X. Okay? Everybody see how I got that? Yes, no, maybe?
Yes.
Cross multiply. What's 36 times 36? Hurry, quick.
I'm getting it. 1,296.
Minus 36x is equal to, what is 24 times 36?
864.
Oh, dang it.
What am I going to do now? Subtract what? 1296. And I should get a negative 36x is equal to, what are those two subtracted?
Negative 432.
God.
What am I going to divide both sides by? What am I going to divide both sides by?
36.
No.
Negative 36. It's going to be like positive 12.
What's x equal to?